Okay, so in today's lecture, what I want to do is this will probably be our final lecture covering arrays, because we really covered all the basics with arrays. Then we covered multi-dimensional arrays. We covered arrays as references and all sorts of crazy things with that. We talked about the variable length arguments. We talked about command line arguments. We even looked at the arrays class. That was a utility class that gave us a lot of cool functionality that we don't already have in arrays. So in this lecture, my last lecture that will cover arrays before we move on to the next topic in Unit 2, which is the dry design, it's going to be the array list. So the array list is a class that's also part of java.util. We'll see that in a moment. It's built on top of an array, but it's a more complex, it's more complex in that there's more functionality to it, but it's easier for us to use. So after I showed you all these things with arrays, which are kind of in this middle ground between a reference type, but it's kind of homebrewed into the system with its own symbols. So it feels more like it wants to be a kind of primitive type. An array list is a pure reference type, but it's going to give us a lot of functionality that arrays won't. And so when you start deciding, hey, I need a container, I need a collection to be able to put data in, I want to show you an alternate choice you might be able to choose from. Okay, so an array list is inside of the package java.util, and it contains the ArrayList class, which you could look up on the API. I think I took the most significant methods and I put sample codes inside the slide deck that I want to share with you. Now, let's start off with some interesting comparisons between ArrayList and a standard array. So a standard array, as you might recall, you have to declare what the length is when you first create it. And sometimes that can be a hassle, right? Like you might not necessarily know how much data you need to store in an array when you're authoring your application. That might be something that has to expand over runtime. Let's say you're taking data from the user and you're storing it into an array. Then you might get 10 items from the user, or maybe you get 1,000, right? You might not necessarily know. Or let's say that you're trying to build a game and you want to create a game that can generate new enemies, and you want to keep adding enemies into your collection, and you want that to grow over time. Well, arrays can be difficult, right? You'd have to create a really big array initially, and a lot of it would be empty. One of the cool things about an array list is you don't have to declare a size for it. You can start it as empty, and you can dynamically add elements to it. And as you add elements to it, it'll naturally grow in size. In fact, you can not only just add elements to it, unlike an array where once you put in an element, it's that set size, you can't expand it, you can't diminish it. With an array list, you can actually remove elements and you can actually decrease the size of it. So array lists are already super powerful in the fact that you can add or subtract items from it, and that's built right into it. So it's a resizable array implementation that gives you array-like methods, array-like functionality. So it also implements all sorts of cool list operations and that we can take advantage of, and we'll look at those over the course of today's lecture. So the class provides methods to manipulate the size of the array that's used internally, and it's what's part of the Java collections framework. Now, I had mentioned the Java collections framework once before. If you recall the utility class we looked at last lecture, which was inside the java.util package, which was called arrays, which gave all sorts of functionality on top of arrays, that was also part of the collections framework. So we're only going to look at two classes from the collections framework, the array list and the arrays. Next class, though, in 2120 in Java 2, you're going to learn much, much more about the collections framework and all the different kind of data containers you could potentially have. And in fact, that'll eventually bring you to data structures, which is all about mechanisms and algorithms to contain data and access data, create, read, update, and delete your data from data containers. And that it could get to be a very, very complex domain where there's a lot of consideration of what kind of behavior you want from your container. Right now, we're going to keep it simple. And arrays are probably the simplest type of container, and array list is just an extension of that. Okay, so we're going to really be kind of looking at the API. I gave a link to the API, the most current version as of today's lecture. The most current version of Java that's available is probably Java 18 that you have. So I have a link there, which if you follow the link, it should bring you here to the API documentation. But instead of reading through the API documentation, I've encoded it into our slide deck. Okay, so let's actually just play around with ArrayList. Instead of having like a lecture where we talk about it, I'm going to open up JShell, which is a REBL. It's an interpreter that allows me to just like plug in some Java code, and we can instantly see what happens with that. So before I can start, I need to import ArrayList, just like anything else from the java.util package. Recall that the only thing that's implicitly imported to our code is anything that's contained inside the java.lang package. So let's go ahead and I'm going to copy this, import java.util.ArrayList. So let's launch our JShell. Okay, so I'm inside a JShell. So here I should be able to import. And now with that, I now have access to the ArrayList class. Now, the first thing, before we can do anything with ArrayList, we have to be able to utilize the constructor. So just like in order to create an array, we had to use the new keyword, and then on the new keyword, use kind of the same syntax we were using to construct or to declare our array. This is going to be more classical of a constructor for ArrayList. So here, the way this would work is ArrayList is going to be the data type that we would use. And so the thing it contains is going to go inside of angle brackets. So this is a little bit different than the way that we declared what went into a primitive array. So here, this will be an ArrayList that holds strings. So we have to declare not only the data type ArrayList if we want to use it, but inside the angle brackets, we then will define what this ArrayList can hold. And that could be any kind of data. It could be integers, it could be floats, it could be more complex types that we'll see when we move on to objects. Then we'll have whatever name we want to give to it. Here, we'll just call it ArrayList. We have an assignment. This would be a declaration. So I'll show an example of an initialization, which means we will declare and assign at the same time. So we have our assignment operator. We use the new keyword to build instances of anything that is a reference data type. So you've again, recall you've seen the new keyword with scanner, right? Have we seen it with anything else, or is scanner the only thing we've really seen the new keyword with? Can you recall? Is this, so it's only been these two? Okay. So then this is the second time we've seen the new keyword really utilized then. So here, well, I guess we've seen it with primitive arrays as well, right? So we've seen it with scanner, we've seen it with the primitive arrays, and now we're seeing it with ArrayList. So just know whenever you want to create a new reference data type object in or instance inside of Java, new creates new things. And then we'll invoke its constructor. And so the constructor is going to look very much like what we have here in the declaration. It's going to be ArrayList, only when on the right-hand side of the constructor, we can leave the data type that's in between the angle brackets blank. We can use what's called the diamond operator. So we don't have to be explicit about declaring string here because it's already been declared there. And then here, we will then also go ahead and open and close our parentheses because we have to do that every time we have a method call. So this will create a new instance of an array list. So let's actually see this in action. So if I go into my JShell and we paste, oh, what do I have here? Okay, so here I can see I now have an array list. And if I type and inspect inside of JShell, I can see, yep, I have an array list. And notice that array list is currently empty. It's showing me the contents inside JShell, and there's nothing in there. Excellent. Can everyone see the terminal, by the way? Is this large enough? Do I need to blow this up some? Is that better? Okay, so now that we've created an array list, let's actually see some of the cool things we can do with it. So one of the first methods we should take a look at is the add method. With the add method, we can put any kind of element that can be stored inside this array list. And recall that the elements that are allowed in the array list are what we declare inside the angled brackets when we first declare it. So if I here created a array list called ArrayList that is designed to hold strings, then I can add string elements to it. And so here, just to give you an example, I'm going to go ahead and add apple, I'll add banana, and I'll add carrots, all to my array list. And then we're going to go ahead and print that out. And actually, we already have our array list built. So let's go into here and just do this new code here. So here, we're going to add the apples, we're going to add the bananas, we're going to add the carrots, and then we're going to print that out. And we can see that we actually get a response. Notice this gives back a Boolean response to let us know that the action of adding was successful. So this is why I'm getting printouts of true, 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 because JShell is just letting me know, hey, that was a function style method that gives me back data and is letting me know it was a successful call. And then afterwards, the printout from my system.out is now showing that I now have an array list that contains an apple, it contains a banana, and it contains carrots. Okay, so there's a overloaded version of this method where instead of just applying the element we want to add, we can prefix it with the index into the array list we want to add it at. So let me do this. I'm going to exit out. And that way I don't have a dirty set of variables. And that way we could see what's happening here between each step. So I'm going to relaunch JShell. I'm going to re-import. Oh, nice. So I'm going to re-import my array list. Okay, perfect. So here what I'm going to do is I'm going to create a new array list that will hold strings, because I can see that inside of the angle bracket during the declaration portion. Then I'm going to add an apple. And actually, let's do this. Let's print this out each step of the way. And then what I'm going to do is I'm going to add banana, but I'm going to add banana at index 0, which means it's going to push itself in front of apple. So after this step, and actually, I'm going to print the results after each add. So here, when I print out after adding an apple, it'll just be apple. When I add at index 0, it should then be banana, apple. And then when I add carrots at index 0, it's going to push banana back by 1. So it'll be carrots, banana, apple. So again, this is a really powerful mechanism to be able to dynamically shift things around inside of an array list as well. Something that would be much more difficult to do with a primitive array. And here, when we print that out, we can see we created the array list, then we added apple, so we get that true response. Notice here, the response is void, so it doesn't let us know whether it's successful or not. But after we add the apple, we have apple. We add banana at index 0, so it becomes banana apple. Then we add carrots at index 0, so then banana gets shifted to index 1, and apple gets shifted to index 2. Okay, let's see what else we got here. The next thing I want to take a look at is a clear method. So there's actually a very easy mechanism to go ahead and just remove everything from your array list if you want to. So here, what we're going to do in this basic block of code is we're going to create a new empty array list. This time I'm going to use integer. Notice I'm using integer as a reference data type. Instead of being in lowercase letters, I'm putting it in uppercase letters, starting with an uppercase, and I'm spelling it out. So let's say something here. Let's test something. What if what if I tried to use the primitive instead of the reference type? What if I tried to use the primitive int? When I do that, notice actually I can't do that with an array list like I can do with an array. So that is a distinguishing factor we should be aware of, is that an array list can only contain things of reference data types. It can't actually contain primitive data types, but fortunately in java.lang, inside that package, every primitive data type has a one-to-one corresponding reference data type that it can match to, that it can automatically convert itself or be treated as. So int, lowercase I and t, is equivalent, the reference data type equivalent to that is integer, completely spelled out with an uppercase I. And it's the same with float, it's the same with double, it's the same with char or character. So here, since this doesn't work, if I go and replace the primitive with the reference, notice now that works. And then I can add integer literals as if it were a primitive data type. And so let's do the rest of this. So here, let's add 10, 20, 30. We'll do that. And if I actually inspect our array list now, no, caps locks. Okay, so we have 10, 20, 30. So now if I do ArrayList.clear, and I go and expect, notice everything is now gone from it. Excellent. The next method actually kind of corresponds to a question you were, I didn't know if you had looked ahead or whatnot at some of the methods that are available, but there is actually a clone method. So the clone method allows us to create a copy of an array list. So here, let's first build an array so we can compare. So I'm going to do the same thing. I'm going to clean up my workspace here. Oh, no. I will then go ahead and clear the terminal. Let's relaunch JShell. Let's import our array list, and let's make this new array list that again will be an integer. It'll hold integers and it'll have the value 10, 20, and 30. We'll add 3 values into there, and I'll inspect it. And I can see, yes, it has 10, 20, and 30 in there. So here, let's check this out. Let's go ahead and clone. So here I'm going to create another assignment. So I'm going to create an array list that holds, oh, it can't be primitive data type though. It's got to be correct this slide while we're here. Okay, there we go. So we'll create another array list reference. We'll call it other list, and we'll assign into it ArrayList.clone. Oh, wait, let me see here. It should be returns a shallow copy. Let's see, object. Oh, do I have to? Let's see if it wants it like this. Okay, perfect. So one big thing to recall is that we have to pay attention to the API and see what the data type is. So this says it returns an object. We'll talk about what an object is in Java, but here I can create a object data type, and now I have my other list. And so now my other list, let's see here, if it'll let me then go and print out. Let's do system.out.println, and let's put in our other list. And here we can see that it contains the same amount of elements, 10, 20, and 30. Okay, so another thing that's interesting about the array list is the ability to query it and ask it if it contains an element. So again, with a primitive array, if you want to do this, you probably have to do a for loop and check each item to see if it's equal. But here we can just do the contains. So in order to do this, let's not do the clone though. Let's do this. Let's do a new array list. And let's see if it actually lets me pass an R list in here into the constructor. Okay, let's start with this. First things first, let me exit out. Let me clear. Let me relaunch my J shell. And let us import. And let's make that first list. So here, I'm going to create an array list called R list. It will hold integers, and we'll add 10, 20, 30. So now if I look at R list, it in fact has 10, 20, and 30. Then here, let's see if it lets me do this. Let's see if I can't create a R list here that holds integers. Let's make sure that it's not primitive, but rather the reference type. And let's correct this slide since we're doing this. Perfect. Okay. And here I'll call this other list, and here I'll create a new array list, but I'll pass in the R list. And in fact, it does let me pass one array list into another array list. So now if I look at other list, I now have 10, 20, 30. So here, let's now go to other list and add to it 40. So now if I look at other list, I have 10, 20, 30, 40. If I look at R list, I have 10, 20, 30. So now let's test these two out. Let's see if on result 1, I'm going to ask other list if it contains 40. And on R list, I'm going to ask it on result 2, I'm going to ask R list if it contains 40. So one of these should be true, the other should be false. So we'll just paste those in. We could see one is true, the other is false. And if I want to verify that, I can just, if this were not in the interpreter, I could do a printout and it would say true and false. So this is just a quick and easy way to be able to check to see if there's a value inside of my array. Another thing that's super useful is the equals method. We already mentioned the complexity of the primitive equals operator, that it only works with primitive data types. And if you try to use it on a reference type, it's just going to compare a memory address to another memory address, which is usually not the behavior you're looking for. So in order to check to make sure your array lists are holding the same data type and have the same number of elements, and those elements are of the same value, we can just call dot equals. Let's take a look at that. And again, instead of this, let's do that. This has to be that, and let's pass our R list into there. Perfect. Okay, so let's start by building these two different lists, like what we have already done. And before we do this, let's exit. Let's clear. Let's launch, and let's import. Okay, so here, we've already seen this lots now. We're going to create a new array list of data type integer. We will add 10, 20, 30 to it, and then we'll use that array list to build a copy of it by passing it into the constructor and then creating another list. So I have a R list and I have an other list. Okay, so for the equals, for result 1, let's check if it's equal. Now we expect they should be because they have the same number of elements, therefore the same data type, and each element has the same value. So here we get back true, right? So, but on other lists, let's go ahead and add to it 40. And now if we look at other list, we can see it's got 10, 20, 30, 40, where our list has 10, 20, 30. So if we do that same thing, let's go up here. Let's do the single line. So here, if I create a result 2 and say R list equals other list, now it's going to be false. So just an illustration that we have the ability to do an equality operation on these. Now, one thing that's going to be slightly different between the array list versus the primitive array is the ability to read data, read values back from it. So instead of using box notation, as you probably noticed, like on a primitive data type, we're using method calls. So in order to get data, we have to use the get method. So let's take a, so we can get the, so we can provide the index into the array list, and it's going to return back the item, the value, the element at that index. So let's create an array really quick, and then we'll take a look at being able to get that back. So before we do this, let's exit, let's clear, and let's launch back into JShell. Okay, so now that I'm back into JShell, let's re-import our array list. Let us create this array that has apple, banana, and carrots. Let me inspect it just to make sure it's exactly what I think it is. Yep, apple, banana, carrots. So now what we're going to do is let's create a string that we will call item, and we will assign into it from our list. We will call the get method, and we will get the value that's at index 1. Okay, and that's going to be banana. And then I could print that out. I could do system.out.print, but we already see, because the interpreter is reactive, that I can go ahead and just see it here. But we can also inspect it the same way we would inside of our normal code base. Okay, in addition to having the ability to get the value, we can also get the index of a particular value. So we can pass a value. We could take a, let's say we have our string array. We can pass a string into the array list and say what index is that what index is that at? In fact, let's try this twice. Let's do this on side. Let's do index 1 and let's do index 2. Because if it's not in there, it's going to create a sentinel value of -1. So here, let's put perfect. Okay, so let's create our array. First, before we do this, let's exit, clear, launch, import, and we will create a array list of data type string. We will add apple, banana, and carrots into it. We will inspect just to make sure we can see it's what we claim it to be, apple, banana, carrots. Okay, so here we're going to do index 1. And from our array list, we will do index of, and then we're going to pass in one of the values that can be held inside of this array list. So we will do banana. And see, this lets us know that banana is inside the array list and it's at index 1. Now let's do the same thing, but let's do cake. And I'm going to change this this variable to index 2. And here this is going to be -1 because cake is not indexed. So the sentinel value is earned. Whenever you remember, a negative index is not a valid index. It's not a legal index into an array. So whenever we get it, we know, oh, that thing isn't there. Okay, there's another method in here which allows us just to check to see if the array list is empty or not. Because remember, this is a dynamically sizing container. So it can start empty, we can add elements to it, so it can be not empty, but then we can clear it and then we can make it empty again. And in fact, let's actually add the ability to clear it. Just to see that that is a thing we can do. And I'll highlight this line here as well. Okay, so let's go here. Let's exit out. Let's clear. Let's go back in. Let's import. Okay, so the first thing we're going to do is we're going to create a new array, but we're not going to add anything into it. And then we're going to query, is it empty? And of course it should be, right? Because we haven't added anything in, so it's going to say true. Now let's add some elements in there, apple, banana, and carrots. So now if I inspect it, I can see, oh, it's got apple, banana, and carrots in there. So now if I query, we can see it's going to be false. It's not empty. And then finally, let's do ArrayList clear. So our list dot is empty, I should now see is true again. And if I inspect it, I can see that it has no elements. Excellent. Now, array containers, anything that's part of the java.util.collections framework. So anything part of the collections framework has something, it has a special class that it can provide to you called an iterator. So an iterator is another mechanism that allows us to walk across the array list to access elements. So far, the only way we've learned to walk across a container, an array, is to use a for loop. Now, we've learned how to use both a traditional for loop and an enhanced for loop to do that, but an alternate way is to use the iterator. So let's take a look at that. Let's exit out. Let's clear. Let's launch JShell, and let's import. Okay, so here, let's create just an array list really quick. Let's add apple, banana, and carrots in there. So if I inspect, I should say I have apple, banana, and carrots. So the next thing I'm going to do is I'm going to call this method iterator on my array list. Notice it's going to return back an iterator data type. And inside of the angle brackets where it says E is supposed to be whatever is the actual data type held inside of our array list. So if our array list here is a string, then this is going to be an iterator to access string elements. So here I will just paste this iterator. I'm going to call my iterator just iter, and it will come from my R list. So on my R list is an iterator method that will allow me to now get access to an iterator. And so notice I now have something called iter. And so for iter, I can actually, let's look at iterators quick API. It's very short. It only has a couple methods, the ability to see if there's a next element inside that we can access. And if there is, then we can grab it. We can get next. So let's try those out. So on iter, I will ask has next, and it's true. So then I'll say, okay, well, then what's the next element that I can access? And it's going to give me apple. And then I can do has next again. It'll say true. I do that. I'm like, now it's banana. I can ask it again, has next. It says true. I get it. And now it's carrots. And then finally, I can do has next and no, that's false. And so if I want to walk across it again, I'd have to grab a new iterator from it. So notice an iterator is just an easy, convenient mechanism that allows us to walk without having to use a for loop. It's actually built very similar to the way the scanner object works, right? Where you can ask it if it has something, and if it does, you grab the next thing. So we saw index of, another method I really want to show you that's part of the array list is that we can also check the last index of as well. So suppose you have two identical elements in your array, index of will always give you the first appearing instance of it. So suppose you want to get the later instance, suppose you want to get the last reference of that element, then we can use last index instead. So let's take a look at this example first, where we are going to have two instances of 10. So let me open up this. Let's clear this. Let's go back into JShell. Let's import our array list. So let's start by just creating an array list here. And we're going to add, it's going to be an integer array list. We're going to add in 10, then 20, then 10, then 30. Whoops. Missed a bracket there. Let's start over. Okay, so let's create this list and then we'll take a look at exactly what this is going to do for us. So, okay, we created our array list. So now if I go and inspect, I have 10, 20, 10, 30. Notice if I do index of, and then pass in 10, it's going to say, oh, 10 is at index 0. But actually, it's at index 0. And what's the other index it's at? Exactly. So if we wanted to get that it's at index 2, I could do last index of, and so now it's going to give me the index 2 instead of the index 0. There's a second type of iterator. So we already saw the iterator class. There's another iterator called the list iterator. It's very similar to the other iterator I showed you, but it, instead of just being able to go forwards, it can also go backwards. So you can ask if it has a next and then grab the next, or you can ask if it has a previous and grab its previous. Let's take a look at that. So here, I'm going to exit out of here. Oh no, not quite what I want to do. I want to clear my terminal first. Okay, let's launch into there. Let's import our array list. Okay, so the first thing we're going to do here is we're going to create an array list of data type string. We're going to add apple. We're going to add banana. We're going to add carrots. Then I'm going to create a reference type of list iterator that will be able to return string data types, because that's what our container holds. I'm going to call it iter, and I'm going to assign to it from array list has that method list iterator. So let's go ahead and do that. So now I have a iter variable. I can do what I did before. I can do has next, right? Okay, list iterator. Oh, whoops. This is not spelled right. That has to be an I. Okay, let's try this again. Okay, now I have an iterator, a list iterator. So now I can do has next, and it's going to say true, and then I'll be able to do next. And that'll give me banana, that'll give apple, that'll give me banana, that'll give me carrots. And now when I would do has next, normally with the normal iterator where it would say false, and then that's it. Here, I can now go backwards if I wanted to. I can go, oh, well, does it have a previous? And it's true. And in fact, I can go to get carrots, I can get banana, I can get apple. And then when I get there, I can go in the opposite direction. I go back forwards again if I wanted to. So this is a really powerful iterator that allows me to go both backwards and forwards and to check to see if there's an element in front of me or an element behind me. And again, you'll learn much more about iterators in the next class in 2120. This is kind of just a preview of what's to come. Okay, we looked at list iterator. Oh, the list iterator also allows you to pass in an index of. So when you create it, you can actually decide where you want to start it at. I could show you that, but it's pretty self-evident. You just pass a number into it, and it'll start you at that position inside of your array list to inspect. So if you want to start at the end, for instance, you could do that, or if you want to start in the middle. Or if you want to see if the index of an element is at a certain part, you can create an iterator then that is at that element index in your array list. Let's say we can also remove elements. So we remove by index. So let's take a look at that. No. So let's jump over here. Let's exit. Let's clear. Let's jump into JShell and let's create an array list. Here I have an array list of apple, banana, carrots. Suppose that I want to remove banana. Then I can go ahead and say, and here I'm going to show you, what's going to happen is this not only removes it from the array list, but notice it says it returns data type E. Data type E is just a placeholder that represents, well, whatever element this array list contains, because that's a dynamic thing. Array list can hold any kind of element. So here, I'm just going to create a variable to grab the thing we're removing out of it. So here, I'll call this item. So string item. So from my R list, I will tell it remove index 1. So here I saw that it had apple, banana, and carrots. When I do this, I now am going to remove banana, and now that's stored inside of that variable. So if I look at my variable item, it has banana, and if I inspect my array list, it's now just apple and carrots. And I can remove not only using an index, and if I use the index, it gives me the element. I can also tell it what object I want to remove. So instead of saying index 1, I could say remove banana. And instead of returning to banana, it's going to return back a Boolean value, true or false, on whether it was successful or not. Let's take a look at that. So I'm going to exit out of here. I'm going to clear, relaunch into JShell. Let's go ahead and import. Yeah, that looks fine. Okay, let's import my java.util.ArrayList. Let's create a new array list of data type string. I'm going to add apple, banana, and carrots. Let's inspect to make sure it's exactly what I expect, apple, banana, carrots. So here, let's go ahead and call remove, but we're actually going to pass in the value of banana. And here I'm going to save the resulting value it's going to give back to me on whether it's successful or not. So that's going to be true. Banana was removed. And if I look at our list, we can see, yeah, apple, carrots, banana is no longer in there. Let's try that with something that's not in there. So let's try maybe a berry. And now it's going to say false, that the remove was not successful because there's no berry value inside the array list. And in fact, if I go and inspect it, it's still just apple and carrots. Okay, in addition to being able to add elements like we've already seen, we've seen where we can add to the end of the array list. We also saw that we can put an index number where we can force something to go at a particular index and it shifts everything behind it. There's also the ability to set. Set is different than add because we list an index we want to set a value into and it just overwrites that value. It doesn't push it back like what add does. It'll destroy whatever is at that index and replace it with this new value. So we'll just take a quick look at that. Let's go ahead and clear. So let's start by just creating a simple string array list. Let's first start by launching JShell, and then let's start by importing our array list. So here we're going to create an array list, and we're just going to add apple. So if I look at array list, I now have just apple. But now what I'm going to do is this is going to return back the element. The element it returns back should be the element that was ejected out, that was overridden. So let's test that out. So we're going to have the string and we're going to get our result. And in fact, I'll make this say item. And so on array list at index 0, I'm going to set banana. So notice it gives me back what was the old value at that index, which is apple. So if I inspect item now, the thing that I assigned from that, I now have the value of apple. And if I inspect my array list, I now see that at the index that was apple is instead now banana. And I could do that again. So let's actually do this. Let's go to array list add. Let's add apple in there. Just so we, no. Okay. So now if I look at my array list, banana, apple, perfect. Now let's go back to the set, and here instead of setting banana, we will set carrots just to show you that there's no shifting. So when I do this, I now am going to have inside of item banana. And if I look at my array list, it's now going to be carrots where banana was, but apple is still at index 1, just to illustrate that it doesn't change anything else except for the index we're setting into. And then when we do set, if we need to preserve that value, if we need to use that value for something, we can save it into a variable because it gives it to us and doesn't just like mysteriously overwrite it. Another thing we can do is, so recall that with a primitive array, with a standard array, it tracks its length. We could do dot length, and that's a fixed value that never changes. But an array list is resizable, right? It starts at size 0. As we add elements, the size increases. So we use a different word for something that's resizable versus something that's not resizable. Length is something that says stone, whereas size represents the current size, the number of elements that's currently in the array list. So we can actually inspect the size of the array list throughout the lifetime of our application, and it can change over time. Let's take a look at that. So let's start by creating this. So it's empty. So if I do size now, I'm not going to bother save. Oh yeah, let's. And of course, size is an integer. It's discrete countable things typically are. So now if I inspect size, you see it's 0. So now let's go to our list and let's add to it Apple. So now if I go to check its size, and here I won't save it into anything, I'll just check it so we can inspect it. So if I check the size here, I can see now it's 1. And so now if we add a new element into it, I can now see that the size is 2. And now if I go to my R list and I clear it, like what we saw before, remember, if I clear it, it makes everything go away. Well, if I check the size, I can see the size goes back to 0. We can also grab sublist from our array. So that means we can give a starting index and an ending index and actually grab just a sub portion of our array list. Let's take a quick look at that. You can see there's a lot of methods. So you get a lot of flexibility with this that you simply don't get with arrays. Okay, let's import. Let's create an array list really quick. That will be data type integer and we'll hold 10, 20, 30, and 40. Let's just double check that. Yep, 10, 20, 30, 40. So suppose I wanted to go ahead and get that middle portion of that array list and save it into another list. So here, notice this returns back a list data type, and the E inside the angle brackets is whatever is the data type that is contained inside the array list initially. So since this is an integer data type, my list has to be an integer data type. So here, let's go here, and I'm going to create a variable that's just called result, and I'm going to assign to it from my R list. I will call that sublist method, and I'm going to give it a starting index of 1 and an ending index of 3. And what it's going to return to me is those middle values, right? The values in between that start and end index. And so if I inspect result now, I can see it's going to be that sublist from my original array list. I can also take an array list and actually convert it into a primitive array. So if for any reason you need to take something that's like this really complex reference type, but handle it in a more array-like structure, it's very easy to do. In fact, we're going to see how to do that right now. Let's exit out. Let's clear. Let's launch JShell. Let's do our import. So we're going to start by just creating an array so we can play around with it. What am I missing here? I'm missing this parentheses. So let's Control C that. Let's exit. Let's just go ahead and clear out and we'll start over. So let's launch our JShell and let's just create an array list so that we can motivate what we're going to do next. Okay, so let's check our R list 10, 20, 30, 40. Okay, so here, this isn't quite what I want to do. I want to do, wait, what is going on here? This is last index of, oh, yeah, this is what I want to do here. Okay, so here, we're going to create a integer array. So here, I'm going to want to create a, well, I might have to do it as an object. Because remember, I got to follow the API. The API says this is an object data type. So let's change this here inside the sample. And it's going to be of a primitive array type. So if I do that, now notice all of a sudden I have an object that has 10, 20, 30, 40. And now that I have that object that I called result, I can now use box notation on it. So at index 0, it's going to be 10. At index 1, it will be 20. At index 2, it'll be 30. And index, well, there is no index 4. I meant to do index 3. I get an array at index 7. And that also means that I have a dot length on it, right? Which is going to be 4. So I can easily convert an array list into an array. And I can also easily convert it into a string, right? We've been seeing it convert into a string implicitly by just doing system.out.print, or I can just invoke the toString method on it and it translates it into a string. Let's just take a look at that. And I think for the most part, that's all the, oh no. Let's see here. Let's create this method. Let's create this array list that has 10, 20, 30, 40. Let's take a look at it. 10, 20, 30, 40. Okay, so here I'm going to create a string variable that I'll call result, and I will go onto my array list and I will call the toString method on it. When I call that toString method, it's going to convert my array into text. And so now I can look at results and see that result is now that text. Excellent. So I think there's a vast number of methods. I went through the API myself and I looked at all the interesting ones that make array lists much more powerful than a standard array. And then I just wanted to create some basic little simple code so you could see it in action. So I think it's much better to be able to kind of play around, like kind of sandbox your code, kind of play around with it to get a better understanding of what's happening. And I think that's pretty much it, though. I think we covered a majority of what we can do with the array list. So that said, does anyone have any questions about it? But how do you feel about the array list versus the arrays that we had spent so many lectures learning about? Do you have a preference? Do you like arrays better? Do you like array lists better? Yeah, really powerful. Excellent. Well, you're free to use either one for homework 5. Homework 5 should be posted. I'll have the due date be next Friday because we've covered everything with arrays. I'll try to get all of the lectures posted onto YouTube this weekend. I have a big due date on Friday. So after that, I'll go ahead and get everything put up on our YouTube channel. Excellent. So if there's no questions, I will go ahead and let everyone out a little early today because we covered all the content we need to today. All right. No questions online. All right, everyone have a great day. I will see you next week. It's Thursday.